All right, so segment 3 went a little long. Segment 4 is going to be probably fairly short, but again, it was just based on the topics, getting into acid naming. And so we were looking at the different systems we're going to have for naming, and I saw that and I thought it's 9 slides, but you're probably going to want to take your time through them. So we'll cut this into our 4th segment. And then we'll look at some base naming as well. So naming acids, the binary acids, when you have hydrogen and just a non-metal, what you're going to do is take the molecular name. So we'll drop the gen from the H name. For instance, like hydrogen, we'll take just that hydro part and we'll merge the hydro with "ide" and then "ic" acid. Okay, so in other words, if we have the name of the molecular compound as HCl, what we'll do is this, we'll take the hydro and then we'll add the chloric acid. Okay, if it's H2S, we'll have hydro and then sulfuric acid. Okay, so hydrosulfuric acid. Now, if it's an oxo acid, acids with hydrogen, oxygen, and another nonmetal element. Right, so basically your polyatomic elements. To name them, it's going to be based on the parent oxo anion name. Okay, so we're going to take the parent ion name. So the ion ends in ATE, then we're going to change that to simply IC. Okay, means you have more oxygens. So the anion ends in ite, we're going to change that to an us acid. Now, the end name with acid to initiate the H+. So naming according to the anion suffix. If it ends in ite, it's going to be an us acid. If it ends in ate, it's going to be an ic acid. So in other words, if we have NO3 minus 1, then the anion is nitrate, right? So it's nitrate. Then we're going to take the ATE off, add ic acid, and it's going to become nitric acid. So here we have SO4 2 minus. That's going to be sulfate. The ATE tells us we're going to knock that off and put on ic acid. And so this becomes sulfuric acid. Notice there's no hydros for these guys, right? So hydro was only if it was an elemental acid. Okay, for our polyatomic acids, there will be no hydro. If it's chlorite, ITE will give us the us acid. So chlorite becomes chlorus acid. Phosphite will become phosphorus acid. Okay, so there's your 2 rules for that. Now let's learn our learning check here. HNO2 then will be nitrous acid. HCN, now this one's tricky, right? Because it's not going to follow our rules. It doesn't end in ate or ite. What's it end in? It ends in IDE. So if it ends in IDE, that IDE sound is coming from the monatomic, the elemental pieces. And so we said, what? Hydro, and then whatever the elemental piece was. And so this actually becomes hydrocyanic acid. Hydrocyanic acid. Tricky on that one. All right, so HClO4. Is it perchlorate? Perchlorite? What is it? And then, of course, once we know that it's in ate, then it ends in ic acid, so perchloric acid. How about HF? Or HF is elemental, and so it's going to be hydrofluoric acid. And then H2CO3, the CO3 name is going to be carbonate, so we get carbonic acid. All right, what is the correct name for HClO4? Good, C, right? What is the correct name for H2SO3? B, sulfurous acid. All right, so naming bases. Again, we have oxides and hydroxides. These are all going to be ionic compounds, and so we're simply going to name them like we normally would name an ionic compound. So for instance, CaOH2, as long as we know that polyatomic name is hydroxide, earlier we learned that we would say calcium hydroxide, and nothing's going to change there. For Li2O, again, we would say lithium oxide. So it's just standard ionic naming. Now for molecular bases, they'll be named like molecules. So they might have their own name, like NH3 is simply ammonia. CH3 and H2, it's got an organic name. That organic name is going to be methylamine. Methylamine. If we have two methyls on the nitrogen, we call that dimethylamine. And of course, when we have all three, we call that trimethylamine. For the molecular bases, for these guys down here, on most exams, I'll probably give you the name, ammonia, and then a comma, and then what that formula is. Right? For the ionic names for bases, I would expect you to know those, and I would expect you to have acid naming under control as well for the exam. So for exam 2, you should know these names. Okay, so that's giving you plenty of time to work on all the different names from ionic, our molecular naming. The only naming that I'll give you a lot of help with is the organic naming. Again, you could spend a whole year in organic chemistry learning the bases of those names, so I won't hold you to the fire for those. And I'll help you with molecular base names. But the other names, by the time exam 2 rolls around in a few weeks, you should be ready for that. All right, so that ends part A of solutions. And so the next segment, we'll begin part B, where we start to look at more reactions in solution.